Hello and welcome to this video. So we're talking about the implementations of NAT. Some publications call them the types of NAT or network address translation. We talked about NAT or static NAT in another video. This is a one-on-one mapping. One-on-one. One public IP is mapped to one private IP. One private IP is mapped to one public IP. It has the benefit of bidirectional communication or bidirectional NAT. The source, the internal network can access the external network proactively, and the external network can access the internal network proactively. The second type of NAT we talked about is dynamic NAT, and dynamic NAT is based on an address pool. So it solves one of the problems of one-on-one, because this time we can have even 10 users using about 2 public IP addresses. Well, the problem with this we saw is that only the number of public addresses we have, the number of users equal to the public addresses you have, can access the internet at any one instant or concurrently. If you have more than users who are more than the number of public addresses you have, then some of them will need to wait for the public address, one of the public addresses, to be free so that they can use it. This is exactly where network address port translation comes in, or ECIP. ECIP is simply a special implementation of this. This is also called port address translation. So what exactly is network address port translation? Now, as I've mentioned, dynamic NAT does not translate port numbers. It belongs to the no port address translation mode, or no PAT. In that mode, the mapping between public and private addresses is still one-on-one. It's one-to-one, but it's dynamic. So if someone goes offline, another person can be using that IP address in the meantime. If someone goes offline, another one can be using that IP address in the meantime. That's the only benefit to it. But it's still one-on-one. So if you have 3 users, you need 3 public IP addresses. If you have 100 concurrent users, you need 100 public IP addresses, which is kind of not really improving public address utilization. So network address and port translation translates both IP addresses and port numbers from multiple internal hosts to the same public address in an address pool. So you realize this is quite similar to dynamic NAT. The only difference is that for each public address, we can convert this private address and that private address and that private address all to this very same public address. But now, public address and a different port number, and a different port number, and a different. We translate both layer 3 addresses and layer 4 addresses in network address. That's why it's called network address and port translation. So it enables a public IP address to map multiple private IP addresses through ports. One public IP address can map multiple private IP addresses through ports. In network address and port translation mode, both IP addresses and transport layer ports are translated so that different private addresses with different source port numbers are mapped to the same public address with different port numbers. Let us look at this example right here. You can look at the NAT mapping table that has been generated. 192.168.1.1 and source port 1032.1 is mapped to 122.1.2.2 and 1025. Look at that. The next IP address is mapped to the same public IP address but with a different port number. Now, theoretically, one public IP address can be mapped to 65,000 private IP addresses, which is way more effective. So we still have an address pool like in dynamic NAT, but for each one address, one public address in the address pool, we can map several IP addresses from the private end. Let us look at an example of this. So in this example, we have host 1 communicating with port 10321, communicating to the web server 200.1.2.3. So this packet will come right to the NAT device. The NAT device will realize this guy wants to go out to the public network, and so he needs a public IP address. His private IP address cannot communicate on the public network. So the NAT device selects an address from the address pool and translates both the source IP and the port number. So it will select an address like this. For instance, after selecting the address, it will change the source address to the selected address, but that's not the only thing it will do. It will change also the source port number to another port number. The destination address and port number will remain the same, and the packet will go to the destination. So it generates a temporary NAT mapping table which records the source IP address and port number before translation and the source IP address and port number after translation. This facilitates the reply, because now when a packet returns, as the server gives a reply, it will hit the device and the device will check the NAT mapping table it generated, finds a match, and knows exactly where packets from this IP address and port number need to go on the internal network, and it will therefore intelligently forward or change the addresses to the addresses that are required to reach the internal network. This right here is an example configuration of network address and port translation. You can see we still need to set up an address group using that command, NAT address group 122.1.2.1 up to 122.1.2.1. You can see in our example right here, there's just one address in the address pool. So SCL 2000 rule 5 permit, we are selecting the traffic, identifying the traffic for which addresses we shall need to translate, and after that we go to the interface and say NAT outbound 2000 address group 1. Now there is an important trick I want to show you here. When we are configuring dynamic NAT, the only difference we have here is adding no part. That's all. Now by not adding no part here, it means we are doing part, and that is network address and port translation. Now there is a special implementation of network address and port translation that we call EasyIP. You realize this is a lot similar to dynamic NAT. Everything is almost the same. The only difference is that we don't add no part, which means that this does translation of also the ports. But what benefit does EasyIP give us? Now, whereas network address and port translation requires an address pool, public address pool, HCIA doesn't. It keeps translating all these addresses from the internal network to the public address of the egress device. The address on the public facing interface on the egress device. This address right here, we don't need to define an address pool, and there is not going to be any address pool. So in EasyIP, we translate both the IP address and transport layer port numbers. The implementation of EasyIP is exactly the same as that of network address and port translation. The difference is that EasyIP does not involve address pools. You're going to see that that makes our configuration of EasyIP way simpler. It uses an interface address as the public address for NAT. EasyIP applies to scenarios where public IP addresses are not fixed, such as scenarios where public IP addresses are dynamically obtained by egress devices on private networks through either DHCP dynamic host configuration protocol or PPPoE dial-up, point-to-point protocol over Ethernet dial-up. This is an example configuration, and as I mentioned, all you need is an ACL to identify interesting traffic for which IP addresses you need to translate, and then go to an interface and say NAT outbound 2000. You don't need to define an address pool. And that, ladies and gentlemen, is network address and port translation, NAPT. This is also called PAT and EasyIP, which is a special implementation of that. I hope this has been informative for you, and thank you for viewing.